Hey, welcome to the Commodore 64 live hangout, the one and only, with Steve Morrow and Bo Gorin, and other people coming soon. What's going on, Steve?
What's up? Let me try to figure out where John went to here. Let's see. Video call from John. John opened up another chat. Okay, wait. I can't do that, John.
Here, what I'll do for John is I'll give him the URL.
Yeah,
And if you go back, you could also put the URL into the description of the YouTube video
yeah, I got it.
and maybe the comments of the YouTube video too, and then people can click it and come right in if they like.
That's perfect. Yep.
I'll go ahead and give it to John here in the little chat window. Bam. This is the one we're in. Send it.
Yeah, I just saw it.
There we go. So now John has been notified.
Question is where the video is. I'm still looking for that. Should be on the Google Hangouts, maybe.
Nope, you gotta go through your YouTube. Go to your events, live events.
You can't get it at Google Hangouts.
Not if you want to like update the description and that kind of stuff.
Let's go back. Let me share my screen again. Can you see that?
Yep, this is where you want to be. From here, you should be able to edit.
Oh, I see the edit button. Okay. Now we can just put the link in there. We're saying go live now. We're already live. That's kind of interesting. Okay, let's click on it.
Yep, go ahead and hit it. And then cancel that. Nope. Oh,
It opens up another window. What the heck?
you hit cancel, right?
We're still using this one. So edit. So what did I do wrong?
Your link's in there. It's just you hit go live now, but then you hit cancel after, like a pop-up.
Oh, you're supposed to click on cancel?
No, click on go live now,
It pops up in the window.
then click cancel.
Oh, right there. I see what you're saying.
Yeah.
And then that records it. Oh, interesting. So backwards.
So now you can hit your live control room there
There.
at the top.
Go live now, right here.
Click on live control room right above your title.
Oh, right there. Link tab, I see. Which computer was package?
Because what we're going to want to do here, we're going to want to you want to actually have the YouTube window open, because if people are in the YouTube video right now commenting, you'll be able to see it. So if
Yeah.
you scroll way down to the bottom, there should be like a public view.
Yeah, I see that.
Go ahead and play that. And then down in the lower right hand corner, there should be a button that like go to YouTube.
Oh, yeah. It's just playing the video.
Yep, on the bottom right hand corner of the window, there should be like a little. It looks like it's a.
I want to.
It should say YouTube down there at the bottom right. For some reason, there's like a white box covering it where I can't see some of it.
Yeah, I see that too.
Right now, comments.
Yeah, I think that's covering the icon you actually want to click on to get to.
It's like behind on the audio too. That's funny.
Play that.
Yeah, we're delayed probably by 30 seconds or more.
Right hand corner, there should be a button that go to YouTube.
All I see is a YouTube icon. I don't see anything.
Yep, at the bottom right hand corner.
Yeah, with that white box right in the way, I don't know what that's doing there, but that's blocking what you got to click on. Here, I can help you with that. Let me get you. Okay, let's say you're live now. It says there's one person watching.
Yeah,
that's probably the icon.
Let me just try the tab again or something. I'm gonna switch the tab again.
Okay, we're broadcasting live. Everything looks good. And what I'll do here, I posted it in the comments there. If you click that, it'll take you right to the YouTube video that we're on.
Yeah.
And you have access to the, go ahead and pause it, and then you'll have access to the comments from there if anyone leaves comments in the...
And it'll keep recording it anyway. That's kind of cool.
Yep.
That's a great idea. Thanks.
Now on here, the comments should appear on the right. Yes.
Yeah, mine. Oh, it's on the right. I see it.
Say, click my name for more C64. There we go. And I'm on the wrong account. Dang it. Yeah, I didn't know you were already broadcasting. You just hit it all quick on me. But that's alright. People can see us setting up. I don't care.
So we should be all able to see everything then. So people can start putting comments on or whatever. So, like, does this send it to their phone too or something?
Does it send it to their phone?
You know how, like, when the announcement, Google, like right now I got it on my phone.
What you want to do is on the Google Hangout itself,
Yep.
where you could like mute the microphone and whatnot.
Yep.
You're going to want to click on invite people.
Ah, just like last time I see.
And then from there you can send it out to pretty much everyone who's in your circle and stuff.
Alright. Got it. Just like I did last time. I'm going to try to make sure I don't end up biting Todd again. Alright. Shoot, I don't know how to edit that.
Okay, it says you have invited people. Okay, so what I got up here, you're looking at the Vice C64 emulator. If you go to Google and you type in WinVice, W-I-N-V-I-C-E, you could download your own copy for Windows. This allows you to emulate Commodore 64 on a Windows computer. You could also get other emulators for other operating systems by just pretty much doing that. Do a Google search on Commodore 64 emulator and then type in your operating system, be it Linux or Macintosh, etc., etc. I figure what we'll start off doing, maybe we could have some fun with some scrolling. I've typed a little program out and get some scrolling going on, and you guys could type it in and follow along if you'd like. The first thing I got typed in here, you'll see it's poke 53270, 199. Now what that poke does is it sets the screen to, it shrinks the border, the horizontal border, the left side of the border and the right side of the border. Here, if I switch it to 200, the border will go back to full. Is my screen share coming through okay, Steve?
Yeah, I can see it.
Perfect. And then if you set poke 53270 to 199, the border will shrink. You can notice the best by the top line there where it says 64K RAM system. You can see the basic bytes free. It's FRE now. The second E is hidden behind the border. So in BASIC, to be able to make the screen kind of scroll around, we could write a little routine. First line, 4A equals 192 to 199. Oh boy, it's laggy. Oh well.
It won't be laggy in the video though. I don't think.
Here, I got two Hangouts open. Let me close one. Free up some processor for myself here.
Let me make sure I ain't got no extra hangouts. I'm good.
Okay. So it's first line 4A equals 192 to 199 step. Now remember, you don't have to necessarily use spaces in between things on a Commodore 64. It'll still know whether you put spaces in it or not. So I know it looks like 4A at the beginning, but it's actually 4 and then the letter A. No, let me go ahead and fix that so it makes more sense. So it's 4A equals 192 to 199. And we're going to want to slow it down, so let's do a step of, say, 0.1. Next line, we're going to poke A into location 53270. And then the next line, we're going to repeat it. So what that'll do real quick is it'll just poke 53270 with 192, and then 193, 194, and so on all the way up to 199. Next line here, we'll do the same thing but backwards. So this time 4A equals 199 to 190. Oh my lord. To 192, step negative. Why is it doing that to me? Negative 0.1. That'll make it count down. So what we should have, there we go. Last line we'll do go to 10, and that'll make it just repeat. Alright, let's see if it works. And it didn't, because I didn't even put the R in there. Okay. Even my computer's lagging real bad, so I don't know how good it's showing up on the screen share.
Yeah, we'll find out. I can see it okay though.
Okay. Yeah, as good as you can see it is how good it'll be shown on the YouTube video. So basically what it does is it just kind of makes the whole screen scoot back and forth by one whole character space over and over, back and forth, back and forth. To be able to make it scroll further than that, we have to actually shift the whole screen over by one. We have to shift every character over one whole space. Unfortunately, we can't really do that from BASIC. We'd have to use machine code for that.
Yeah.
There we go. Oh, I can't even read what's on there. There we go. So there you go, guys. Type that in there, and you can make your screen move back and wiggle back and forth.
I know some of those bits in that register, that address 53270, are controlled by other things. Did you notice that? Like when you typed in and you changed the color, it looks like the multicolor is hooked up there somehow too.
That's true. Memory location 53270 controls the horizontal placement of the characters. Also controls the border. Is it the big border or the littler border? And it does multicolor too. Multicolor on or off.
Bit 4. Yeah, there's that.
So when you look at why I went between the location between 192 and 199, if you break those numbers down into their binary code, you'll see which bits are set. Basically, I had it set to not multicolor, so that multicolor bit is off. I got the border shrunk, so that bit is set. And then I just go back and forth between the bits that are used to move the characters back and forth.
So is that doing like a mask or an OR? Is that like a, you know, like when you're masking something with the AND statement, or the, I'm still a little fuzzy on those.
Well, let's take a look. Location 199, for example.
Mm-hmm.
And I'll have you do this, Steve. Location 199. What is that in binary, 8-bit binary? I know it's, what is it, 128 Well,
I'd have to go get a binary converter. You're asking me a tough question.
let me see if Google can do it for us. I bet it can.
Yeah, there's a lot of converters out there. Although you're gonna make me regret my chart up here. Shucks, they ain't here anymore. I had a binary conversion chart here one time, but I'm missing half the book. So that ain't gonna happen. Wait, maybe it's in the middle. You ever heard of the Programmer's Reference Guide?
Oh, yes, definitely.
Mine is totally damaged, but it's got all the binary stuff and everything you're asking about.
Here we go. I got it on mathisfun.com. Looks like decimal 199 comes out as binary as 1 1, 3 zeros, and then 3 ones. Okay.
Liberal does everything, of course, but I don't know where.
Okay, so 199 equals,
to the back.
in binary, 1 1 0 0 0 1 1 1. Okay. So Steve, if you go to one of your books, Mapping C64 perhaps, or even a Programmer's Reference Guide, if you look at location 53270 there,
Yep.
it should be able to tell you what these bits do.
Yep, that's where I was telling you earlier, the bit 4 is multicolor. I just didn't understand, like, is that anding, like bit 4? Like you ever say like and 128 and 64? I know that those will mask. I've been playing with them and I noticed that they'll turn off certain bits, and the OR will kind of restore them if I'm not mistaken.
Yes, with and, if you type a number and it with a number that's one of the bits, like 128 or 64, 32, 16, 8, 4, 2, 1. Of course, that's each number for each bit.
Yeah, okay, I get it.
Let's say the number 33. The number 33 will be 32 plus 1.
Yep.
So, say we want to turn off 32. So print 33 and 32. You should get, looks like that turned,
Yep.
Okay, so that one put on only bit 32. So when you type in 33, which is 32 and 1, if you AND it with 32, it actually takes out 1. It's so tough to explain.
Yeah, I see what you're doing now. It's all based on that chart you put up, the 128, 64, 32, how the computer sees the powers of the numbers.
Yep.
That part always confused me too. You said that kind of makes a little bit more sense.
So, okay, so this is 199. Here's the binary of it, and the way it makes sense is here, here, here,
Yeah.
here.
I guess that makes sense.
Like that. Okay, so say we want to turn on this bit, 32.
Mm-hmm.
If we do and 32, it should give us, it's telling us that it's off. Maybe it's or 32.
Yeah.
Yeah, there we go, 231. All right, let's see what we got with 231. Let me convert that real quick.
I really gotta find my chart. See if I could even remember where it is.
So 231 is 111 0 0 1 1 1. Okay, so it did it. So by doing 199 or 32, we turned on that bit 32 by making it from 199 to 231. So yeah, I got an OR. And I think to turn off bit 32.
So if we wanted to turn on OR 16, we would just say OR 16 with that number. It's that simple.
Yep. So if we want to turn off bit 32, let's say we're at 231. I think what you got to do is OR. I think it's 250. Oh,
I'm going to warn people this is a little advanced.
I think it's OR 256 minus 32. And this should give us 199, or else I'm way wrong. It didn't. So I think it's and 256 minus 32 to get 199, and that didn't work either.
So a lot of comments on YouTube kind of tell them where we're at right now. They're not watching.
Ah, there it is. Okay, there we go. So to turn a bit off, you got to and 255 minus that.
So that's how the OR works. It kind of subtracts from the number.
Well, to turn a bit on.
That's masking, so that would be turning off.
Yeah.
Yeah, I get it. I never had a problem with the and. It was the OR that always threw me off. It's like, okay, how does when you're and an OR and a byte together, what the heck does that mean? But you're looking at which bit you're going to use, and then I guess after that you're looking at the bit you're going to be setting, the one you're going to eventually be using, I guess. That's what I understood.
You know what? I haven't studied much about OR.
Yeah. I
know that's how you could use and to turn on and off specific bits. So, say
OR will set the bits. I know that. Mask is like getting rid of them, or is like turn them back on, because when I played with my sprite demo on that, it would turn certain bits on and off by playing with them.
Ah, okay, wait. See, I confused myself having stuff on it that was wrong. Let me get all this extra crap out of here. So that the screen makes sense. Okay, so to turn a bit on, you do OR and the bit number. So we wanted to turn 199, we wanted to turn bit 32 on, so we did OR 32 and it turned it on. And then to turn the bit back off, you do and 255 minus the bit number.
That makes sense.
And then that brings you back to having the bit turned off.
Because 255 is the total number of bits.
Yeah, 255, that'll mean that the binary number is all ones.
I see.
So what do these bits mean on 53270? What's this one, the 128? So that one's on right now. I think it says it in your memory mapping book. I don't know if you...
For which? For 53270?
Yep.
For 128, it just says bit 0 to 2, 3, 4, 5, 6, 7. I don't see anything much more.
Yeah, these ones here, bit 4, bit 2, and bit 1.
Oh, that's
these three control the zooming this, moving the text back and forth.
So bit 0 is the 1?
Yep.
I see how it works. I always think it was the other way. Because it's calculating, that's why powers of 2, that makes sense.
So these three will handle zooming the screen left and, scrolling it left and right, because that's hence why I could go between 192 and 199. Like if I turn all these bits off, that should be that'll be 192 now. 128 plus 64, what does that equal?
I see how it works. It says bit 6 and 7 are not used. So I guess it only uses certain bits.
Yep, see? That's at 192 right now.
Hmm.
So right now, with only bit 128 on and bit 64 on, the number that's poked in the memory would be 192. And then you can add 1. That'll make it 193,
Big top.
93, 94, 95,
So much better.
199. So what's this one do? The one I got blinking there, bit 8.
Is that bit 4 or bit 8?
If you're counting 0 through 7, I guess it's 0, 1, 2, 3, bit 4.
Yeah, I think that's how it is. It says enable multicolor text.
Okay, so let's try that. Let's test that. So bit 8, we want bit 8 to set. Alright, so what is 199
yeah.
or 8? 207. So if I poke 207 into there, that should put it to multicolor mode. Let's try it. Ah.
Shift the screen.
Yep. So now we're...
How did you
And I can't even read it.
put it back to 199?
Yeah, if I put 208 in there...
So it seems to be adding an extra bit to it or something. Let's see, bit 4. Oh, so 1 says multicolor, 0 is off. There we go. That's why. You added a 1 to it and you turned it on.
Oh, okay.
Interesting. So they even take advantage of the individual. See that you got the bytes in the bit.
See, if I poke 53270 200, let me freshen everything up here. We'll start from 0 here. Let's say 200, that's the default. Okay.
So now you need to look at that binary number for 200, put it in there, and start playing with the bits. I get it.
Yeah, so 200, that's exactly what I'm doing.
That's the way they teach you in these books. Sometimes it confuses the heck out of people.
Yeah, that programmer's reference guide, it took me a long time to figure out. Like, I was able to type into programs and get the little balloon guy going and all that kind of stuff that's in there.
Yeah.
But the way they do it makes it really hard to understand exactly what they're doing.
Mm-hmm. Like, for example, if you want to print text, not text, if you want to print numbers to the screen, you have to mask out, and you have to OR bits, you have to use a little bit of math. I have programs that do that, but I never understood it to you. You said this, and now I get it. It's kind of like fine-tuning the numbers it needs to show, which would be 0 to 9. And then all they're doing is they're just taking them in zeros, ones, tens, hundreds, thousands, and sticking them in that order, and that's how it calculates, which bit you're using, or which ASCII character. Did that make sense?
Mm-hmm.
Yeah.
So here's the default state of this memory location.
Mm-hmm.
So you said this one's not used?
Wait, for 53270, it says bit 1 is multi-cut. Well, I'm sorry. Let me get back. Yeah, 6 and 7 are not used.
Okay, so these two have nothing.
Everything up to bit 5, it doesn't say anything after that.
So then, okay. How about...
Up to the 16. 1 does a 16.
How about bit 5? What does that one do?
Video chip reset. 0 is normal operation. 1 is video completely off.
Oh, okay.
Might be a blanker.
So yeah, if we set this bit, it'll actually it'll extend the border to cover the whole screen.
Oh, I want to see that.
And that is just like when you load from tape. Like the border will be the whole screen.
Oh, so it'll turn off the text then, right?
Yeah, like if I turn that bit on, my light blue border will be the whole screen, and I won't be able to see anything else until I turn it back. Let's try it out.
Yeah, why not?
What is it? 200. I got a white or 32 to get it. Yeah.
Yep.
232. Let's try it. Poke.
And it gives you the number. I get it.
And this should make the whole screen light blue. It didn't. Didn't I set it? It's
Uh,
set. Maybe it's 216 I gotta set.
Yeah, let's see. Yeah, one is completely
Okay,
off.
it's multicolor. Okay.
You have to add a 1 to it. I'm starting to understand. So try 233. Did you try that? Huh, what the heck?
Nope.
It says video completely off. 1.
Maybe WinVice don't want to do it. I don't know. So yeah, if I turn on bit 8, it sets it to multicolor mode for me.
Were you using bit 5 or bit 4? This is for bit 5, which would be the 16, right?
I'm pretty sure they do it this way, right? For what the bits are.
8. Change to 16. That's bit 5. Well, no, I'm sorry. We started at 0. You were right. My brain runs a minute.
So yeah, if that's turned the screen off, it should be 232.
Okay.
It didn't do anything.
We could bore him to death with that one, but
216 turns on multicolor, then 208 should shrink the border, right? No, that's if I turn it off. I gotta make it 199. So which bit is doing the border then?
let me see. Let me read through a little bit. Bit 3. Select the 38 column, 40 column. I think that's it. That's how you change the columns.
So it's okay. Yeah, because when it's set to 200, we're looking at
Yeah, that's
the
it.
screen. The screen scrolled all the way to the left because
Yep.
of bits 0, 1, and 2. Those bits 0, 1, and 2. Those handle the screen scroll position, right?
Mm-hmm.
Okay. So with 0, 1, and 2 all set to 0, the text is all the way to the left. And with that one on, that sets the screen to the bigger border. Now, when I go down to 199, I actually tell it to move all the text all the way to the right and then shrink the border.
It enlarged the border, didn't it?
Well, I guess shrink the screen, I guess.
This central part, that's what you're saying.
Yeah.
This book is incredible, now that I think about it. I think I paid like $30 for this book on eBay.
That's a good price.
I was like, you know what? That's a rare book. I don't think this is my original. It might be. Let's see. Hey, it might be my original. Yeah, I think it's my original. I don't know. It's got a number on it. No, 1895. Yeah, this is my original book. Yeah, cool. I did something really dumb years ago, though. Before, YouTube, before the internet, I had all these Atari programs. I know you're not an Atari person, but I had all these Atari programs I had spent like 3 years writing, and I just pitched everything, thinking I'm moving on, including everything I owned for the Atari.
Let me guess. Did the old lady encourage you to do that?
No, this was after my divorce, but then she already stuck it in my mind before that it was a problem. And I guess it was still ringing in my mind like after the divorce that maybe I should part with it. Maybe she had a point. Yeah, for some reason, though, I hung on to my Atari magazines. I would not part with those. And I kept all my Commodore stuff. I said, I got to keep something of myself. Made the right decision there, I think.
Yeah. I feel bad to hear about getting rid of the Atari stuff, but you know what? You still got plenty of retro stuff.
Yeah. I found another disc the other day, and I don't know if you noticed the site, I'm still putting up those programs, and it's got like a bunch more programs on it, and actually came across one where I did a raster example. I was playing with the raster lines on the Commodore.
Yeah, I think I saw one where you had some raster bars going, color bars, right? Was it doing
Well,
color bars?
this was a different one. It was like animating the raster lines. I know which one you're talking about, though. I got that from the Atari example and converted it to the Commodore. But there was, I'll have to put it up there. I don't have a video for it right now, or I don't have it on the website, but I'll put it up there later. Pretty cool, though. Maybe I should just throw a video up there and show people those. Like do a raster video or something. That'd be kind of cool. Yeah, that's a great idea.
So you want to find out something really funny about the Commodore 64 when you're trying to do vertical scrolling in BASIC?
What's that?
Because so far what we've done is we're moving text back and forth horizontally.
Mm-hmm.
We can theoretically do the same thing vertically if we use memory location 53265.
Yeah, that one's good. That one's really interesting. That was used by Pitfall too, quite a bit.
Here, write a quick program up using 53265, like kind of like the one I wrote here for 53270, and see if you get the text to go up and down like how I had it going left and right.
You mean use that and just switch it out for the raster? Got my program up here.
I'm not sure if you could use 192 through 199. You'll have to double check the bits on that. But it's basically the same concept. You just poke 53265 with whatever number within the 7-digit range to make it go up and down.
Yep, I got it. I'm gonna try those numbers anyway just to see what happens. Probably gonna convert to high res.
I think 53265 handles the extended color mode too, I think. I don't have any books up or nothing right now. I should, but oh well.
I'm going to save the default for 53265 is 27, so if I lose my screen, I can come back. Yeah, it blank. That's where the blanker is. It's in 53265.
Ah, okay.
Turns off the whole screen.
Now, right now, I just see the YouTube video on your screen.
Oh, okay. Let me get that up.
Okay, now I see you. Okay, there we go. Now we got two Commodore 64 screens, so we can confuse our viewers by talking back and forth and having it switch.
Oh, so we can actually bypass both of them because how did it do that? That's kind of cool.
Yeah, if unless you have something one of the two boxes highlighted on the Google Hangout, every time I talk it'll show my screen, and then every time you talk it'll show your screen.
Actually, that makes sense.
So I'll go ahead and go to mute for a second, so then we don't do that back and forth.
Well, these bits didn't work, so let me look at them in the book here. Find scroll is bit 0 to 2. Bit 3. It's very similar to 53270. Oh, bit 5 is bitmap graphics mode. I don't have a binary converter here, but I'm going to put them up here.
Here, I'll do it real quick. So you said the default is 27 there?
Yep.
Okay, let me switch over to the I'll switch to
Binary number.
show my binary. So 27.
Binary number needed for 27. For those who can't hear it, which is default. It's 53265. You know what's really interesting?
Here, I have the binary number for 27.
Let me get it.
It's 000.
I see it.
Oh, you got it there? Okay.
Yeah, it should go away. I don't see it. Okay, I got 00011.
Then 011.
011. Like that. Right?
00011. Yep.
Okay. So that's 27. And
Yeah, 16 plus 8 plus 2 plus 1 should be, yeah.
So now let's see. Um, I don't want to get off on a tangent, but I noticed the Atari, if you ever studied the Atari and the Commodore 64, they both take advantage of the bits that way. I think a lot of computers, but you notice the Apple computer really never took advantage of the bit setting and all that. That I know of, but I thought that was kind of interesting contrast. And if you ever notice how close those registers are, it's almost like the same person somehow wrote it. I mean, was it written by Bill Gates or? I would know.
So I think it's you got to so you're at number 27.
Yep.
So you got to subtract the 2 and the 1. So then what?
Oh, so I subtract from this.
So so try 24.
So what do I change up here? Which bit are we using? Because this is a fine scroll is 0 to 2.
Yeah, we're gonna see how 4 is 0, but then 2 and 1 are both set to 1.
Uh-huh.
If you poke 24 into there, into 52265, you'll be turning off 2 and 1 because you'll be subtracting 3.
Right.
So if you poke 53265 comma 24, that should have your screen. That should scroll your screen all the way up to the top, so that the top of the screen will be into the border.
What was the number again? I'm sorry.
24.
Yep.
Okay, so you want to go what, between 24 and 24 plus 7?
For those who want to know what we're doing.
Between 24 and 32, I believe.
There we go.
Okay. So yeah, if you go between 24 and 32, you should be able to get this and back and forth the same way how I did it. You should be able to have the screen go up and down.
Ah, interesting.
But when you write the program and run it, you're going to see something very interesting happen.
Let me make sure I don't erase all this stuff on the screen here. So what was it, 20?
For A equals 24 to 32, I believe.
Are we stepping 0.2?
Yeah, sure.
Let me save these in a line somewhere. That's like, shoot, you know the insert on the Commodore? Yeah, fine. Try it again. I'll have to type them out every time. Interesting.
Now, if you loop it back and forth, you should see a very interesting artifact on your screen as it's scrolling.
In my this.
Yep. Yeah, there you go.
I think I stuck that line in there.
And then 70 go to 10.
Also, to keep it in the loop. Interesting.
Now you should see, I could kind of see it too, you should see like weird black things popping up and weird little crazy stuff.
Text too.
Commodore 64 has a glitch in it called a bad line.
Yeah, heard about this.
And I've always hated this because I wanted to use this soft scroll along with being able to, if you hold the down arrow down and the screen, everything scrolls up, you know what I mean?
Mm-hmm.
I always wanted to combine soft scroll with scrolling down to be able to make a smooth scrolling game in BASIC, like a guy falling down a cliff,
Mm-hmm.
or maybe a race car game where you're racing downwards.
Yep.
But you can't smooth scroll in BASIC vertically because that's what you get when you try.
That makes sense. It's too slow, right?
Well, it's not that it's too slow. You saw what happened. You got a bunch of garbage popping on the screen randomly.
What if we translated that to assembly code? What would happen?
Well, that would work. What you'd have to do is have your raster beam off the screen whenever you switch that, and it won't do it. Because the reason you see that happening is as long as the raster beam is somewhere on the screen, in which with basic we can't control where the raster beam's at. If the raster beam's on the screen and we hit that bad line, that's when you see the garbage. So you always have the raster beam somewhere off the either in the top border or the bottom border or in the oh, what do they call that when the raster beam's off the screen altogether? Because 50 times per second or 60 times per second, the raster beam goes from top to bottom.
Mm-hmm.
But when it reaches the bottom, it actually goes below the screen area for a very short time too. It's out of the display area, so it gives you a little bitty space where you could make drawing changes without tearing the screen.
Makes sense.
I had to utilize that in that scrolling game demo thing I wrote. When you scroll up and down on that, you won't see those artifacts because I always wait till the raster beam's out of the viewing area before I move anything.
Mm-hmm.
But in BASIC, you can't do that, so for all intents and purposes, you cannot smooth scroll vertically in BASIC.
Interesting.
Of course, you could write a little assembly language and call it sys
I was trying to do that right now.
and have it move the screen that way. And then as long as your raster beam's out of the viewing area, you could fix it. It'll work that way.
Yeah, this tool that Todd did is so awesome. Already got the image converted. So 53265, oh wait, that would be X, that wouldn't be right. We just need to store it in the 53265 if we don't want to do this.
Yeah, I don't think you need to do the TAX command.
Yeah, I thought if I had to transfer, yeah, you're right. I was saying I had to transfer those numbers in, so I just need to load in. What am I doing here? 3265. We need to take the values of the immediate values and store them into the absolute. So that's what I was trying to do. I was trying to get these values into here. Is it TAX, TXA, or TA to transfer these values into here?
Well, you don't have to do that. You could LDX number 24, then STX into 53265.
TX, that's right. Yeah. Looks like STX.
Yeah, make sure you got your run statement, your numbers right there.
I solved that problem today. Solved it, but I'm trying to remember where I put my book. It's over here. I printed out the whole opcodes listing. What I've taken to doing is going to work and distance in my spare time when I'm not taking a call because I work in a call center. I'm disassembling assembly language.
Oh, cool.
Fast time, faster. Instead of just like read a book, I'm like, I can do it anytime I want, but this is my passion. So now I got to do is look up the STX on here. I don't know if I can show you real quick what I'm doing here. Switch out my camera view for a second. Can you see my camera?
Yes.
So this is what I did is I just printed out the chart. It's probably backward, but you get the idea.
It's coming in right. Yeah, see, Google Hangouts, what Google Hangouts will do for you, it'll mirror image it, but for me, it doesn't. I don't know why it does that. I guess Google wants you to see yourself mirrored because you're used to seeing yourself in the mirror, maybe? I don't know.
Egotistical. So it's 142. Okay, so we would increment through this, which is 232. And if we don't slow it down, it's going to be super fast. Maybe we should set it to a joystick routine or something. It'll run so blinding quick.
Yeah, the screen would probably just look like an earthquake or something.
250. That's why I love hand assembling everything, because you learn so much more even though it's slower when you want to write smaller. So guys, if you guys want to write smaller assembly language programs, do it this way, because it's easier to learn from the basics instead of just open up a compiler and try and look at it with this. This way you're looking at basic and you're looking at assembly language, and you kind of use them together, if that makes any sense.
Yeah.
And of course, what you got to do is you got to load bytes in memory. We got a lot of things going on here in this program. Okay, so let's just, yeah, I wish there was a way to like insert. Do you know how to insert these characters? Like if you want to insert this, shift this over. If I hit shift control, it does that. It doesn't work. The insert button doesn't work.
There is a way. I know Commodore 64 has insert. Whoa.
That was all.
Cool.
That's like a copy or something.
You pasted the website in there.
Yeah,
I don't know what the on an emulator. I don't know what keyboard what keys to use on my Windows computer to emulate the insert on the Commodore. I also, because I don't have an extended keyboard on my laptop, I don't have the keypad on the side with the number pad on the side. I'm also not able to emulate doing a run stop restore, unfortunately.
It's similar to Commodore layout, so I think it might be shift. Let me see. No, maybe it's shift and control. Oh well. Well, anyways, we're gonna save line 10. We're gonna get rid of all these other ones. We're gonna convert this into assembly language, everybody, or machine language, if you will. Look at the top of the screen; it's still kind of cut off the top part of the screen. And then we're going to count the bytes, of course. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A safe place I usually use is 49152. That's your memory address. And I've got to read it, darn it. Read the byte. Then poke it. Like so. Save to be on the safe spot. What's this thing called again? Bits, shift screen. What are we doing?
To move the screen, to move the text on the screen up and down.
I was trying to figure out which bit were we working with. We were working with.
Oh, we gotta go between numbers 24 and 32, I think.
So bits 3 and 4. Okay. So I guess we're just call it. You say shift. Bits or something around there. Shift screen. Doesn't matter what you call it. Okay, let's see what happens here. And out of data, what happens? There's 9, what the heck? Oh. Okay, so guys, what's going on right now is we don't have a data statement, so it's not able to read any of this stuff. So we need to create data statements for this. That's how the computer reads in the bytes. Oh, I stuck that 170 in there. I wonder if that's going to screw up anything. And why are we seeing out of data now? What the heck happened? I don't even see what I just did. I forgot to didn't create a line number. Okay, so guys, what's going on right now is we don't have a data statement. So
Oh, hey, John. Make sure to mute the YouTube video.
oh, yeah. Welcome. Okay, so what we need to do is we need to activate the machine language now. Cross your fingers. Let me save this puppy again. You want to save, for those who want to know, if you look next to the P key, you're going to press that and get that at symbol. Press the 0, and you just hit colon and whatever, and it'll rewrite over the program. It's called shift screen. If you don't, you'll see the splashing thing at the bottom, which means it's not. There you go. She's adjusting her camera.
Yeah, I'm sort of new to this.
Screen, look at that. Okay, I think we lost it. Let's see. It's still there. It just went through. Oh, I see. It went through all of these bytes from 24 to 255 because I didn't set a compare X. So we need to throw in the compare X. What was your number again? Was it 32, Bo?
Actually, if you poke 32 in there, what's going to happen is you're going to blank the screen.
Yeah. So what was the bits that we needed again?
Let me see here. I know you got to go to 31. 31 between, let me see. Okay, it's between 24 and 31.
Okay, so I used 31. I think we should be good.
Yeah.
So 248. How many extra ones did I add? 2 more?
Gotta love the listy. I love when it does that.
What's that?
When you type list where it says ready, and it comes out listy.
Oh, yeah.
I've done that so many countless times.
Alright, let's see here. There it goes. So now it's working. It's just going so fast we're not seeing it.
Here, I'll tell you what I did is I wrote a quick little assembly routine. And I get my screen share up here. Is that coming in really terribly?
No, I can see it. I'll convert it over here. Like
Okay.
to your screen.
Basically, what I'm doing with my code here is at memory location 251, I'm going to pretend location 251 is location 53265. So to use this routine, you just poke whatever you want into location 251. That's why you see LDX 251. And on the next line where it says left 0, that's a little loop that basically is going to set my raster beam to the bottom border. I'm checking memory location 53266. This gives you a number between 0 and 255 that tells you where the raster beam is. If it's, you know, between, I think it's between 50 and 250 maybe. I believe it's between, if you do a LDA 53266, if you get a number between 50 or 250, your raster beam is on the screen. So what I did on my code here, I'm checking location 53266. I'm checking, is it at number 252? And if it's not, then don't do anything until it is. Once the raster beam is at the bottom of the screen, that's when you run the code, which is basically just storing 53265. Now the reason I have to do this is, like I said earlier, to scroll the screen back and forth vertically, you have to have the raster beam out of the screen to do it. Let me know when you got all that code, and then I'll go ahead and run it and show you how it works, and it should have fixed that little artifact error you had earlier.
Alright, let's see if I did it right here. Yeah, that was correct. So I gotta change the bytes. Yeah, I got it.
Okay.
Let's save this as another one.
Okay, so now I got Commodore 64 up. Here's the program I wrote that's going to go along with my little assembly language routine.
Okay, I'm good.
All right, I'll go ahead and run this program, and let's see if it works. It should the screen should scroll up and down without all the garbage. Let's check it out. Bam. Hey, it did it. Of course, now we got this little black bar that keeps popping up at the top and bottom. And that's because I didn't I didn't shrink the border, or I didn't expand the border on the top and bottom to hide that black bar. But can you guys see it? See it going up and down?
I wonder why mine crashed.
Did you write that basic program like what I got showing up here?
I was trying to write it in assembly language.
Well, it's both. It's a basic program with a little assembly routine in it.
Oh, so you got the assembly running with the basic program. I see what you're doing.
Yeah, that little assembly language routine I just wrote, whatever you poke into memory location 251 will be transferred to location 53266. But the raster beam is out of the way. The raster beam's off screen. That's why I got that little loop there checking 53266. Is that coming through okay, John? See the screen going up and down and stuff?
So when you're branching like that back to that line, is it ever jumping back to basic?
Yeah, let me switch back to it here. Yeah, my code just does one little thing, and at the very end, it's just RTS.
Oh. Well, I didn't see that store, the extra register. Wait a minute, I missed that.
Yeah, just whatever's in location. It says load X with 251. Oh boy. Make sure to set the raster beam to the bottom border.
Yeah, I got that.
And then store it in 53265, and then return to basic.
That's my problem. I didn't put the store 53251, did you say? What was the store, the X register?
53265.
Oh, okay, I see what you're doing. So I need to convert that. I got it. We're not going back to basic. Double check the numbers here. Can I see your code one more time, Bo? Maybe I got one of the numbers wrong.
It should be on the screen share there, no?
Oh, you put it. Oh, I see what I did wrong. I put I converted this. Yeah, that's. I think that's what it. 208. I forgot why it crashed. 17 and 18. Doesn't seem to work when I type it in basic for some reason. It should just go back to the ready prompt, but it's not. It's clearing the screen like that. That means it's not breaking out of the back to basic.
Yeah, let me check here. You got L3. Wait a minute. Your code's different than mine.
What's different?
Your first line says LDA 53266. It's supposed to be LDX 251.
Wait, I didn't see that up there. Okay, that's what I missed. Okay, let me just add an extra line in here. You didn't have it all on the same line. I didn't see that. So 1251 like that.
Yeah, the very first line should be LDX 2, or not LDA, but LDX 251.
You put me to my test. How fast can he disassemble it? So that should be right there, right?
In your line 2000, I'll make sure you have it LDX 251.
Oh, yeah. Oh, LDX, yeah. Good point. Yeah, otherwise it's going to load only the value and it's not going to increase it. Yep. Shoot, what is that? 166. Puppy, save. Yeah, I get used to that clear screen. Out of date. Oh, what did I do over there?
You might have to soft reset and then load that back in. Because I noticed that too. Whenever I start poking in the location 49152 and up, it'll give me an out of memory error until I soft reset.
Well, I also didn't have this clip though. So that's what the soft reset does. Oh, and this was also screwed up. Yeah. This, guys, is why you need a compiler, but for those who want to learn the way that people done it without a compiler, this is how you learn back in the days. I'm old school. I didn't start with a compiler. In fact, one of my first demo routines I inserted into like that for that car racing game, I wrote all that just for data statements. So,
There is a benefit to doing it that way because then you're able to have it. You can print it up and people can transfer around as a type-in program. That would, that was one of the big good ways to transfer programs around was to have them type-ins because then you didn't have to have an expensive disk, you didn't have to have a tape. You could just have it on a piece of paper, on a couple sheets of paper.
Yep, but mine's still blanked out for some reason. Oh, probably this one. So you're going back to this one? Not this one, right? You're going to the 251? Are you branching back to the first line?
What the first line does, see what this program does is it takes whatever's in memory location 251 and stores it in the memory location 53265.
Mm-hmm.
But there's a delay in there. It delays until the raster beam is out of the memory area or out of the drawing area, so that when we store in the 53265, we don't get that garbage. So all this program's doing is it's taking in whatever you got poked into 251, it pokes it into 53265.
Mm-hmm.
So then, that's what that. So that little B and E part, that's just checking the raster beam. LDA 53266. That's just checking where the raster beam is at.
That's all that's doing.
And I want the raster beam to be at 252, which is way at the bottom, so that.
But in your Syndico, were you branching back to the top line or to the line below it?
The line below it.
And was that load
Yeah.
the register 53? Because I don't see your code. I'm trying to go by memory. So I have load accumulator 53266.
Yes. Load the accumulator is 53266. Compare number 252. B and E left 0. So left 0 needs to go to that second line.
So I did have it right the first time. Two, 249. Yeah, it worked earlier. Just what it did is it blanked the screen. It didn't come back.
Yeah, all this will do is whatever you got poked into 251 will poke into 53265. So you want to make sure to write poke 251, 24 or something before you run that.
Oh, that's why you have the basic code in there. I was trying to do it without the basic code. Yeah, so I have to stick it in here somewhere. You say 24?
You got to poke that into 251 though.
251.
Yes.
To this?
Your line there should say poke 251, 24.
What am I doing? 251, of course. Because we're incrementing the 251 dash.
Oh, not POC.
Thanks, simulator. So there we go. Let me just save it again anyway. Okay. Look how fast it runs.
Okay, so now poke 251 31, and then run it again.
Oh, say that again?
Actually, just type in poke 251, 31, and now sys 49152. There you go.
So this is how it's playing with the bits. I see what you're doing here. Just shifting them into that. Interesting. That's cool.
So now we could do up and down vertical scrolling without all that garbage, using 251 as a a pseudo.
So we're scrolling the screen though. Are we still able to like scroll it through memory? Have you got that far yet? That'd be like like in games they actually scroll like through Commodore's memory.
Well, we'll have to load a bunch of stuff into memory first, and then
We could just scroll garbage, like I showed in that demo I had before. Just for now.
all right. Let me see.
Try that. We can always write the character set later.
Okay. I will go ahead and see if I can get some code written up real quick for that. Let me switch my screen share over.
That'd be cool, man. Be on the way to making some real hot games here. That's what I promised everybody. I said I was going to make an ebook, and I just kind of like logged out on it.
So the way scrolling works to get things to scroll continuously and not just a little bit, first we got to go through all 7 pokes of 53270, and once we reach our limit, we got to shift the whole screen over by 1 character space, and then we do it again.
Are we doing horizontal or vertical? Let's just do vertical. We're concentrating on one or the other for now.
Want to do vertical? All right.
Yeah, since that's what we're doing here.
Okay. Let me
Vertical is easier, I think. Maybe not, I don't know. Well, we got this far, so I might have used vertical.
Let me think of how to start. I have to start this kind of over here. Okay, let's see. So we got to go between 31 and 24. All right. Can you guys see the code I'm typing in here?
Yeah, I can see it.
Okay.
I was trying to communicate with John. And one other thing to be aware of is whether people are speaking your language too.
Okay, so the way I'll do this is
We're gonna have something.
okay, Steve, if I count from 31 down to 24, does that make the text scroll upwards?
What?
Say if for A from 32 to 24 step minus, does that make this text scroll upwards?
I'm going to use it as a quick demo. 32 to 24?
31 to 24.
Oh. And that's in 53266 or 65?
6.5.
Okay. Testing. Oh man, it goes so quick and fast, you can't see it. Okay, so I have to stick with it somewhere. Can you see that? I can't tell what it's doing.
Yeah, I just see the garbage.
I don't know if it's going up or down.
Yeah, you're gonna want to do it as pokes. You're gonna want to poke it into 251 and do that sys so that so it won't do the garbage.
I could just slow it down, right? Oh, it's still going to be too fast, so we can't really see which way it's doing. Basic's too slow to handle that. So in assembly code, say that again. So I'm going to go through. I'll change this compare statement. Is what you're saying. So we're going to rewrite this whole thing.
All you gotta do is change line 4000. Instead of poke 53265, do poke 251, comma A, and then sys 49152.
That's what I can get in there, right? And next after it, like that. Do we want to stick the loop inside, right? Because we're going to keep repeating it.
Yeah, it looks good.
Gosh. So freaking slow. I mean, it's too fast, so freaking slow it down.
So to me, it looks like the text is scrolling up.
Yeah, I guess
And then it's jumping down and then scrolling up and then jumping down and scrolling up. Okay. So
right.
yeah, so if we go from 31 to 24, that's going to make the text scroll up. That's what we didn't know. Okay.
Try to slow loop to slow it down a little bit.
Yeah, just do the in your line 4000 there, instead of step -1, do step -0.1.
Oh yeah, we could do it there. Yeah, I was going to try to do it in some point. Oh shoot, I got to insert the statement again. Let's stick this on separate lines. Or where did that come from? There it goes. It is going up. Can you see it?
Yep.
It's going up. Man, we actually got strong. That's awesome. We're on our way, peoples. Now all we got to do is point it to memory. That shouldn't be too hard, right?
So this is the first part, doing the fine scroll. But we can only, as you can tell, we only could scroll 7 pixels with a fine scroll. So to get that 8th pixel, we got to do a hard scroll.
Yep, a coarse scroll. I remember this coarse scroll, fine scroll rule. Inside of the loop, right? So we're going to do it somewhere inside of this loop.
Yeah, we'll have to rewrite that. I won't be able to necessarily use this code as it stands.
I have an example here somewhere.
I think the way we want to do it is just where we'll type in sys49152, and we'll have the screen scroll up 1 pixel every time you say sys49152. That'll do the fine scroll and the hard scroll, so it'll know what to do. And every time you want to just scroll the screen up by 1 pixel, you just do sys49152. So let me go ahead and write the code for that. Let me get it up here. Get my screen share up. Here we go. Okay. So what I got here, I got load it with 53265. Check to see if it's below 24. Wait.
Let me catch up here.
So you want to check if it is 24. Okay, yes. We want to check if it is 24. If it is 24, we want to jump. Now, Steve, do you understand that little loop I got here where it says LDA 53266?
The 53266 means learned from the absolute value of 53266, of course. So you're reading what the bytes are in that value, or in that memory address.
And do you understand what's in that memory address?
Right now, I don't know, the code doesn't stay on the screen long enough for me to see it.
Well, no, I mean just at memory location 53266. Do you understand what that memory location is?
Good point. So the raster compare register. Yeah, the horizontal scan line. There we go. Makes sense.
Exactly. So when we LDA 53266, it's going to give us a number between 0 and 255, right? And what's going to happen is, 50 times a second or 60 times a second, the raster beam goes from the very top of the screen to the very bottom of the screen. The very top of the screen, it'll come back 0, and the bottom of the screen will come back 255. To get into the bottom border, we generally want to be at about 250, 252. That's why I have LDA 53266, and that's why I'm checking to see, is it 252?
Mm-hmm.
So once I do that, basically it'll pause until the raster beam is in the lower border somewhere. And then we'll run the code. So the first part of my code here is my screen share showing up okay for you?
Yeah.
Okay. So the first part of the code here, I'm checking 53265 to see where it's at. We want it to be between 31 and 24.
Mm-hmm.
So I'm checking, is it at 24, which means is it at the top of the soft scroll? If it is, we're going to branch to left 1. Left 1 I haven't wrote out quite yet, because what I have to put for left 1 is going to have to be a coarse scroll. So if 53265 is not equal to 24, which means that it's higher than 24, somewhere between 24 and 31,
Yeah.
then all we're going to do, we're going to set our raster beam to the bottom border and then decrement 53265 so that it moves everything up 1 pixel and then go back to basic. So now I'm writing the code, say we're already at 24. We can't go to 23, we got to switch it back to 31. But first, we got to do a coarse scroll to move the whole screen up. So what kind of code do you think we should write to have every character move up 1 character space?
That's a good question. I wanted to hold an example I have. Maybe that'll be helpful. That I found on the internet.
Sure. If you could find a code that just shifts the whole screen up 1 character space real quick, that'll save me having to type it up.
Mm-hmm. It's a pixel scroll. It pixel scrolls in every direction, but I haven't figured it out yet. Why didn't it come up? Where's my freaking PDF? Oh, I gotta look up the book. I don't have the link. Shucks. The name of the book. Oh gosh. What happened to my freaking link? Stop working. It's called 40 Best Machine Code Routines for the Commodore 64. Bomb Jack site. So I'll put the link down here. You'll have to download the PDF. The Bomb Jack site where you get all the Commodore books at.
I got you.
In this section, almost to the bottom, that says machine language or semi-language. He needs to put some links on here. Oh, wait, it's at the top. Let's see. Click on machine language, and it's the first one there, the yellow one. That's a great book. And let me find a page while you're downloading that.
Now, which book do I want?
The one that says 40 best machine language routines for the Commodore 64. Looking at the chapter.
Okay.
Chapter
Best machine call. Okay, gotcha.
So chapter 6 is what you want in the book.
Wow, Bomb Jack sure does use a slow server.
Oh yeah. Why did Google send me a verification code? What the heck?
I hope I can open the PDF without crashing my computer. I'll try.
Download it. Doesn't take that long to download it.
Yeah, but I mean, with the Google Hangout going and the Commodore 64 emulator going, and the I don't want to overtax my processor. All right, what we got here?
I really cool book.
And it did crash on me. Dang it.
Did it shut down 64 Studio too?
No, it just it actually just minimized Adobe for some reason.
Oh, okay.
So you said it was in chapter 6?
Uh-huh. That's where they all start. Let me get the page for you. Be faster. It's page. Let's have it. Page 47. It's got all scrolling directions from left, right, up, down. The one we're looking for is chapter 8 and 9 or page 55. Okay.
Okay, pixel scroll left, pixel scroll right, pixel scroll up. Here we go.
Yeah. And I can even decode it in regular decimals. You don't have to figure out the hex. Those are my favorite books. To chew on that one for a little bit. You see how he's doing it? He's masking 248 with 50. It's kind of similar to what you're doing.
So he's putting it into.
Which means he's taking off the 7 bits off of it. I see what the N247 is doing. It's getting the top 7 bits.
So he's got 2 routines here. And the first one we might not need. Well, maybe we do.
It's doing the same thing as yours. It's just masking off the bits. He's using a byte counter too for something. Oh, he's keeping track of the scan lines. That makes sense. This makes way more sense to me now. When I looked at this before, I'm like, what's he doing? Now I kind of get it.
I don't think this routine. I think this routine only does it like the program I just wrote. I don't think it does the coarse scroll part. I think it only does the soft scroll part. Because I don't see in here anything but 53265. See, we got to move like location 1024 and 1024 plus 40, 1024 plus 80.
Let me see if he did that in one before it.
Oh yeah. Oh boy, he did it. He did it as speed code. Ooh boy.
I think you're supposed to jump on it too. That's kind of cool. It's a great book.
Yeah, I like this. Thank you.
Mm-hmm. Get us closer to our goal. And soon we'll be selling these games. We'll be the hottest thing on YouTube. Well, maybe not the hottest, the video games are obviously the hottest, but like, old school, check us out. We're writing the best Commodore games. Now that I know how to actually finish one task at a time. That's very important, because if you move on to one task, another task, and you don't finish the first task, then you pretty much screwed yourself. And that's life lessons.
Okay, let's see here.
Oh,
So I got LDA 1024 plus 40, comma X, SDA 1024, comma X.
he does that in the one above. Did you look at that one?
Yeah.
We're going to scroll right and left.
Yep. Yeah, that does. That moves with moving everything right and left. I'm surprised that he did it as speed code.
What do you mean by speed code?
Remember on the other time I was doing the Google Hangout with you, we weren't broadcasting, and I had the screen like going left, and you had a joystick where you were able to make it go.
Yeah.
Now remember, my code was real small. It wasn't much bigger than this. It was like, I think it was maybe a 1.5 screen big,
Mm-hmm.
And I had a loop going. I didn't have like 101 LDA, SDA, LDA, SDA.
Mm-hmm.
I did a loop. By doing a loop, though, you have to use processing time to check if the loop ends. Now, speed code, a lot of demo coders call it speed code. Instead of using a loop, they just do LDA, SDA for every single memory location.
I get what you're doing.
It takes up a lot of memory,
But it's faster.
but yeah, right.
Well, that's how they get the time split, right?
But I don't know if I want to do speed code because I don't want to type it all in. I just want to do the. For this, I think I'll just do a loop.
Just for now, but I mean later if we have to.
So how you could help me here is I need 1024 is the upper left-hand corner of the screen, right? Memory location 1024 is the upper left-hand character space on the screen.
Yep.
1024 plus 40, that puts you into the second line, right? On the left side?
Yep, 1064.
So if you poke 1024 plus 40, comma 90, does something appear in the second line on the left-hand side?
You say that again, 1024 plus 90?
Poke 1024 plus 40, comma anything.
Yeah, it does.
So it puts it in the second line. Great.
Mm-hmm.
Okay, so that's what I need. I need, since you got Commodore 64 up, and I got the C64 Studio up,
Mm-hmm.
what is the... So it's LDA 1024 plus 40. What's the third line? What number is it?
Hold on. Shucks, I didn't time it. 1104.
Okay, so I want to do LDA 1104 and store it into 1064. And what's the line after that?
1144.
And after that?
1184.
Again?
That would be 1224. I'll see if you wrote it in the book in here anymore. Nope, you just use the accumulators.
I don't think I need to do it this often. I don't need to do all 40 lines. I could save more space.
Just try a few for now.
Okay. So far I got 1, 2, 3. What, I got 5 lines.
You just scroll a portion of the screen. I mean, we can just quickly get it to take one section and scroll it like it's going through memory, and we got it.
Okay. You know what? Yeah, give me one more line. What's after 1224?
1304. We lost John.
Yeah.
You probably couldn't hear us or something. I didn't see if there was anything you saying in chat. Let me refresh here for a minute.
Okay. You know what? Yeah, give me one more line. What's after 1224?
1304. 1324.
I sound like such a dork. Alright, so far we got 1, 2, 3, 4, 5, 6 lines.
Then all we gotta do is just change that load accumulator, whatever, to a memory location. Once we get it, we can scroll through that area in memory. That's what I did with that scroll demo. Cool, man.
Okay, so let me check my code here. Check what's in 53265, see if it's 24. If it is, go to left 1. Okay, so before I do that, before I do the hard scroll, I have to
Fine scroll.
reset 53265 to 31. So LDX number 31. Store X in 53265. All right.
I don't know how to text you while you're doing stuff.
I think I'm ready, at least for 6 lines. Not for the whole screen, but for 6 lines.
Yeah, that's fine, as long as we can still get a portion of the screen. That's almost close to halfway down.
Alright, so it worked to move it up 1 pixel. Let's see if we can get it to go up all the way. Here we go. Watch that Commodore 64 Basic V2 at the top. Let's see what we get.
Yeah, I am. Uh-oh.
Oh, wait a second.
When it hits the 7th line, it's gonna flip.
Ah!
Yeah. Well, I wonder if that's why he used the M.
Alright, I did something wrong real bad here.
Blanked out.
So compare to 24.
Let's see what he did. Are you still there?
Yeah, I'm just looking over my code, seeing where I went wrong here. I honestly don't even see where I went wrong.
Let's try to erase here. I think this is going to be a real popular video. The one thing I noticed that Todd does, though, is he cuts out parts like where you're slowing down.
He cuts out parts?
Yeah, like if he's ranting too much about something, he'll like, I've seen people that like slice their video up to get to the point. I think that's what makes people more interested in watching what you have to say.
So it looks like for some reason at the top of my code here, in the top of my code, I'm telling it to load the accumulator. What's in location 53265? Check to see if it holds the number 24. Ah, I think I figured it out. Okay, hold on here.
I'll go back to my bitmap screen again.
Can you see something wrong with the first few lines of my code?
53265 compare 24, that one?
Yeah.
Mhm.
All I'm doing is I'm checking if 53265 equals 24. Then if it does, jump to left 1. Otherwise, don't.
Where's left one going?
Left 1 is here, and that's where it does the hard scroll.
Oh, I see.
But for some reason, it's never jumping the left 1. It's always just
So it's never-
something here ain't working. Yeah.
Well, when you first scroll up 53265, isn't it just going to have a 27 in it? Because that's default.
Right, right. So if I...
Oh, 24 is the default. Okay, my bad. That was for 70.
Well, 24 is the text scrolled all the way up to the top that it could go on a soft scroll.
So you got that right. It should be going to left one.
But it doesn't.
That's freaking weird.
LDA 53265, compare 24, branch if equal to left 1. What is wrong with that?
Maybe it's going there, but it's jumping back out of it and not coming back in it or something. Like doing it one time or something.
Here, let me debug this. Okay, so right now 53265 is set to 27.
Mm.
If I do a sys 49152, this number should now be 26, and it is.
Yeah.
If I do it again, it should be 25. Ah, it's not 25.
But it's throwing off a bit somewhere. What if you,
So see, now it's set to 24. All right, Dad? And now it's 23. See, it's not supposed to go to 23.
yeah, that doesn't make sense.
But what was that 153? In your machine language, or in your mapping Commodore 64 in there, is there any bits in 53265 that are quote-unquote unused?
Well, I mean, bit 8 is not used. It uses all the way up to bit 7. I don't see anything unused.
So you said bit 8 is not used?
Yeah, bit 8 is not used.
Okay, so what that means is that bit 8 might randomly turn itself on and off.
Hmm.
So let me test this out here. If that bit 8 randomly turns itself on and off, that could confuse my machine code. Let me see here. Yeah, see there? It keeps switching between 27 and 155.
Interesting.
So yeah, that bit is randomly turning itself on and off. Does it tell you why it's doing that in there at all? Because right now all I'm doing is just repeatedly printing peak 53265 and it's switching between two different numbers over and over.
What would that be? I'm trying to think. I don't see anything like that.
That's what I thought though. If there's an unused bit, that means I've figured that out the hard way. Like if it says it's an unused bit, that means it could randomly turn itself on and off. So that's probably why my code ain't working, because it's randomly being 100 something and randomly being 20 something. So we're going to have to do an or an and. Wait.
That must be why they do it. It probably gets rid of all the other ones that the computer tries to use it for. Because that's not what masking does, it only centers on those bits.
Right, I need to mask out that unused bit.
See, we learned something new about what the mask is used for here. Interesting. They use AND 247 in the demo. Then you have to store it back into 53265. I've seen that in a lot of books, from the Atari to the Commodore. So I guess if it works one place, it works all places.
So they use AND 247 in there?
Mm-hmm.
Well, that gives me 19.
Well, they load 53265 and AND it with 247. So what's in 53265, 24, and then you ANDed it with 247 and you got, what was it again? Let me do it real quick here. And maybe we need to reset the screen. How do you reset the screen without losing the code? Is that soft or hard?
Your basic program will be erased if you do any kind of reset.
Darn it. There's no freaking reset key.
Okay, so I did AND 247, but it's still giving me two different numbers.
Did you store it back into 53265?
Well, I'm just printing peak 53265. See, now I'm getting either 128 or 0 over and over again. That ain't gonna work for me either. Maybe I need to do an or.
So if you look at my example there, you'll see that's how, oops, that's a typo. That's how they do it with the AND there.
Okay.
I guess somehow it just saves it right back in without losing. Maybe it prevents the processor from using it for something else because it's happening so quickly.
For mine, I think I have to do or 128. Because when I do or 128, now it's fixed. I'm not getting multiple numbers. But, wait a second.
How did you figure out what was the 128? Did you take out a bit or something?
Yeah, you said bit 8, right?
Oh, you just took out a bit.
Yeah. Okay, so I think that's right. So that's what I got to do with my code here. I got to add or 128. So that should do it. Let me fix it. I gotta do what? To do an OR on the accumulators, or A, ORA, right? Yeah. It's OR number 128. Alright. Alright, let's try it. See if we got it right this time.
Yep. And then it's moving.
That's nice. Have my mouse fall down.
Hmm. You using the wireless mouse?
No.
I was using them for a while, but I got tired of changing the batteries.
Man, still didn't do it right. Ah. Maybe it's not OR 128. Maybe it is what you were saying. And 247.
It's interesting to see what happens when you play with them now.
Yeah, did you see that?
Uh-huh. Because AND 248 is only getting the bits 0 to 7. Or is setting them, so I think it's allowing more bits to enter. He explains that in the book. Or somewhere, I read it somewhere.
This is the first time I've ever played around with the vertical scroll.
Mm.
Even though I've done it in that one, I did it in that demo.
I so badly wanted it to work because I want to write a scrolling racing game. That would be a cool thing. Like one of my favorite games on the Atari 2600 was Grand Prix. You ever play that game?
Grand Prix?
Yeah. That was well, actually, that was a side scroller. Yeah, they made a bunch of them on the Commodore 64 though, but like Blue Max is a real common one. That's a cool game. Commando. So what happened?
And number 247 didn't work either.
Did you store it back in the Pi 3265?
Well, what I did is at the beginning of my code, I just loaded it in, ANDed it. Yeah, I can't do it that way either, kind of, because then I can't compare it to 24.
You have to store it in there. Trust me, I've seen it on the Atari and the Commodore. It works. Whoever thought of it, it works.
So I got an LDA 53265 and 247, then put it right back in there again, like that.
Yep. You can get rid of the compare. We don't need that.
Well, do I know I do need that compare because I need to know when to do a hard scroll.
Oh, that's what you're using that for. I see.
Yeah, remember we start off with 53265 having 31 in it. 31 puts the text all the way to the bottom of the soft scroll, and then we decrement 53265 until we reach 24,
I see what you're doing.
and then we do a hard scroll and reset 53265 back to 31.
I get it.
Okay, let's see if it works.
Man, what the heck? I noticed they're ending with 247. Let me kind of read what their code's doing here for me. Why are they jumping out of this thing? Instead of type this, run user type run this. In fact, let me just type in theirs and see what theirs does, just for kicks. Yeah, I'm lagging.
Yeah, WinVice is showing me a good time here by lagging funny. Like it'll randomly want to one spacebar push equals like 10
Yeah,
spacebar push.
that's what mine's doing now. The heck? It's skipping numbers, okay. That sounds silly, but I waited years to see this stuff working, to understand it. I spent months one time just deciphering it and gave up on it. And I got into college and I got too busy.
So when I set 53265, man, when I poke 31 into there, and then I run a loop just to read the peak of 53265 over and over, it keeps going back and forth between 31 and 159. So what is 159 and what is 231? What bit is that that's being turned on and off here?
Good question.
So let me get the binaries here. 31 is 0001111. All right.
Yeah. Is it because we're both running WinVice? Like, why is it lagging so bad now?
Yeah, it's kind of irritating to do that. I hate that right now.
Yeah, shut down some more windows. What other kind of processes can I shut down? There's nothing else running. I shut down Excel. Even though I need Excel, and I don't need Excel, I can calculate here. Oh man, you can't find scroll this far.
All right, so on my screen share here, I got number 31 and number 159 both translated into binary. And it looks like it's that bit 8 is toggling itself on and off, on and off.
So it's probably being used by something else. That's why
So, yeah, so when I'm doing a check to check for number 24,
here somewhere.
if it's doing like, if it's showing like 157 or something instead of 24, that's why my screen is garbling up instead of scrolling. Hey, Matthew Graham, what's going on, man?
just sit here watching.
Yeah, we got dual Commodore 64s going.
Yep.
So I think what I could do with my code here, it's dirty, but why not just check for both 24 and the other number? Get rid of all that. Them Commodore 64 old schoolers are going to fry at me for this.
Probably so. But they're not around.
It'll work though.
Yeah, but they're not around. I already been trying to figure out where they've gone to. And they wrote all these games and they don't even exist now.
So it's going to be either 24 or 152, it looks like.
I'll check it out.
So in my code, I'm going to check for both 24 and 152. That should fix it.
Alright, let's see here.
All right, man, I think I'm ready to try.
Fingers crossed.
All right, here we go. Oh, man.
That bit 8 is a pain. Get wrong here. Man, this ain't lagging. Never carry the byte. Absolutely. Doesn't know what to do.
Okay, let me debug again. Let me find out why it's not doing it. Okay, so it went from 26 to 25. Let me do it again. Should be 24 now. It is. So now when I run it, it should scroll the screen up by a character space and not blank out on me. Let me do it. It didn't. See, now it's 23. It's not supposed to go to 23. What is wrong with my code, man?
I don't think there's anything wrong. I think the computer's taking advantage of those bits. 101. What they call that, the interrupt processor in chip is taken over.
Yeah.
Like basic.
So why isn't this working when I check when I LDA 53265 and compare to number 24? Why is it not branching when equal to 24?
What bit is 24?
I just had it up. 24 is
4? D5 is bitnet graphics mode, which may explain why you saw that.
24 is bits 3 and 4 set to 1 and everything else set to 0.
Okay, so bit 3 for 1 is 25 rolls, bit 4 for 1 does nothing, doesn't say. Bit 0 blanks the screen if it's in bit 4. But somehow it's going to bit 5, because that's the bitmap graphics mode that I saw on the screen. The mastery.
Well, here, let me show you what 24 is in binary on my screen share.
Let me grab my pen. That time I need to find a pen. Hold on, let me write it down. Is that it? 0001100?
Yep.
Okay.
And then 152 should be that, but with a 1 at the front.
Got it.
And it is, see? So 152 is 100,
Let me check them real quick.
and 24 is 000. So for some reason, I load the accumulator with number 24, but when I do compare number 24 and branch if equal, it doesn't branch if equal.
It's not getting whatever bit 24 is, which would be 16 plus 8 is 24, so that's 0, 1, 2,
Right.
4, so 3 and 4.
Right.
Let's see the 3 and 4. Okay, let me read up on this a little bit. Register. Okay, wait. By setting the bit to 1 or a shortened 24 row display, setting bit short display is created by extending the border to at the top. Fine. Affected by that. Okay, bit 4 controls the screen blanking feature. When it's set to 0, no data can be displayed on the screen. Did it blank out?
Yeah, it just keeps going. It goes all the way through every number. It won't stop at 24 and then jump where I want it to go. It like ignores that it's 24 and just keeps on going.
But in your example, you're only using bits 128, 16, and 8 on both. So what is that? 128, 64, 32. That's 224. So basically, you're using bits 3, 4, 16, and The whole screen to be filled with the color of green. It says the VIC-2 and the 6510 both have the address of the same memory. They must share the system data bus. That's in bit 4. Sharing the data bus means they must take turns whenever they want to address memory. That's interesting. What's the data bus? What is that?
Got me.
I didn't need time for that. Says the VIC-2 chip must delay the 6510 for a short amount of time while it's using the data bus to gather information for text or bitmap graphics. Must delay it a little more sprites are awesome. When you set the screen blanking bit to 0, that's bit 4, which is 8, and you don't have it set to 0, these delays are eliminated. It's allowed to run at its full speed. I wonder if you took that and put that as a 1. The screen makes the processor have some percent. Let me see what that binary number translates to. Put in 28. Oh, that's interesting. At 156, was that the number you saw earlier?
What was that?
156, was that the number you saw earlier?
No, I'm jumping between. I had it poked to 24, and I'm jumping between 24 and 152.
No, I mean when you printed out those numbers earlier, did you see 156 in the list? You remember?
No, that's the two numbers I saw. It was going back and forth between 24 and 152.
156 seems to be controlling. If I'm understanding this correctly, it's in bit 4. Because what I did is I took and I turned on bit 4 and I converted it with the binary number and it comes up 156. And it says here the VIC chip must delay it for a short amount of time while it's using the data bus to gather information. Apparently it's using that bit for something, for the data bus. I wonder if you...
I need to do the right and or operation to mask that out.
Yeah.
So I need to be able to get... I'm doing it now. I'm trying to figure it out now on my Commodore. Let me switch over here.
This is really interesting now.
I got to be able to print 152 and do a correct and or and have it result in the number 24.
That's the number you're using. Okay. So 152. Let me see what those bits look like. For true Commodore assembly language people, they're going to love this.
See, if I do 152 minus 128, I'll get 24. But I can't do that. I gotta figure out how to do it on either an and or an or. 152 or 256 minus 128. That didn't do it.
It just blows my mind when you think of the team that must have built this computer.
Ah, there it is. There it is. I gotta do and 127. That's what I gotta do.
Wait, I saw that number earlier somewhere. Oh man. I was playing with the bits and I came across these numbers and I kept playing. I was like, okay, maybe if he changes this bit out to 127, because I think that makes sense. 255 minus 127 is 128.
So I gotta load the accumulator 53265 and number 127, and then that should set it where I want it to be.
Hmm. Don't forget to store it back in there.
Well, that wouldn't really do me anything.
Oh,
Because all you're doing is you're basically saying poke 53265 with peak 53265 by doing that. Now, come on, this has got to work. This has got to work.
this is so cool. It's giving me ideas for future videos. I love this. I get the time to do it. And really we'll blow their minds now. We'll go down to the bit level. We lost Matthew. Like people, what are we 2 over their heads? What's up?
Yeah, it's probably weird because it's just 2 Commodore 64 screens, and it's like, what are these guys even doing?
How do we engage your audience?
It still didn't do it? Come on, man. You gotta be kidding me, man.
It's still using that bit 4, and it says you can't. It's being used by the data bus. So you use 127. Let me see what that translates into over here. Oh, I need to do it backward. Does this thing do it backward? Oh, it does. It's all ones. Used every single bit with 127.
No, 120. No, 255 would be all bits on.
Oh, why did this give me all ones? So this doesn't work when you type in a decimal number then.
All I can see what you got right now is just your Commodore screen.
Oh, let me flip it over there. I'm doing all kinds of stuff over here. How do I get that back up? Oh, how to share that part of the screen. So right here, the binary converter.
Yeah, the bad thing about that is it doesn't put the zeros in front. So how many ones you got there?
8.
No, that shouldn't. It should be, I think, 7.
Oh.
You got to put a 0 in front of all that then.
Oh, dang it.
Yeah, that's the bad thing about that program. It doesn't want to give you all the bits, all the 0 bits in front.
Well, how do you get the 127 then?
Go up to binary and put a 0 at the very front of it.
I already know what it is anyway.
So it's 0, 1, 1, 1, 1, 1, 1.
It's 127, so it's every bit except 128.
Right.
So basically, every bit up to bit 7 is being used. That wasn't too hard.
Yeah, that's what I was doing, is masking out that very first 0. Because that's the one that's toggling between 0, 1, 0, 1, 0, 1.
Oh, that's what you were doing, I see.
But it's not working.
Because what is that bit being used for? That's bit 8. And bit 8 is unused, right? Yeah, bit 8's not being used.
Yeah, but it keeps toggling 0, 1, 0, 1, 0, 1. So that's why I'm getting 24, then 152, then 24, 152.
Oh, so you're going back and forth between those two.
No, that's what the Commodore's doing. Yeah, if you type in the program 10 print peak 53265, 20 go to 10 and run it, it'll show like 2 different numbers toggling.
Yeah.
Because it keeps toggling that unused bit on and off.
Hmm.
What I might have to do here, because for some reason the AND number 127 ain't working for me.
Yeah, that's pretty ironic.
If you type print 152 and 127, it comes back 24, and that's the number I want. But the code is still not jumping to left 1.
Hmm. too tired to search for an apartment tomorrow. I gotta be out of this place in a month.
Oh man.
I don't live in the greatest area, so I'm trying to get out of here.
Yeah, you were saying that you and a buddy might be moving out or something together or something like that, right?
He does most of these videos, but he backed out on it. He only wanted one specific apartment, so I guess he finally figured out we don't think the same way. So more power to him. Let's see, bit 7. That's why I've always learned to live on my own. You know, you have to take care of yourself.
It's a good way to do it.
Oh yeah. And nobody else gonna do it. As my dad taught me. Skip him. Alright, now I can think. We're curious to see what their scroller's gonna do. On that book.
Yeah.
We're trying to convert their code and see what it looks like. They use one part to set up and they use another part to run it. Interesting. I'm just laughing at the comment you put on there. I was looking at YouTube and he's like, "Can you keep up?"
Okay, so I put a deck 53280 into my left 1 routine, and I learned that I am jumping into left 1. Let me show you how. Let me show you how I learned that.
I missed that part. You're jumping into the left 1. Oh, you mean the branch.
Yep. So
it should be working.
Well, watch what happens here. Now, when the border changes colors, that means it branched to left 1 successfully.
Mm-hmm.
So let's do it. And see? So it did branch into left 1.
Ah, so that's what that. Yeah, I read about that earlier.
So I am branching into left 1. I'm doing something wrong in my left 1.
Wait, I read about that. It changes the border color.
No, I did that myself.
Oh, you did that?
Yes, I put into my left 1 routine here to decrement 53280 to change the border color to notify me that we went into left 1.
Excuse me, I missed that part.
So we're getting into left 1. So my code up here was fine. I need to fix it all.
You just wanted to check to make sure that part was working.
Right.
There was something I read earlier about controlling something. Anyway, to where we were. When you get time, read this. Map in a Commodore 64, read that section. It'll probably really open your eyes to something that maybe we're not seeing. That's totally got me intrigued now. I mean, you don't know. You just opened up a whole door of videos. Well, thank you.
Yeah.
But I still got to stay consistent. I'm trying to teach them step by step how to write simple, basic, or machine language programs. If I start jumping off somewhere else, people are like, "Why are you going over here?" I'm like, okay, stay in one spot. Because I have the ability to go everywhere if I want to, but I have to control myself. I've learned to rationalize that and think in one section at a time.
Okay, so now I know that all this code is right.
Mm-hmm. Because it's jumping in the branch, yeah.
Yeah, I was able to successfully do the sys 49152 enough times and then get to where it changed the border.
Yeah.
So it's down here where I'm messing up at somewhere. So let me see what I'm doing wrong here. Set the raster beam to the bottom, that's what I want. Load the accumulator with the value of 31 and put it into 53265. That's working okay. I think it's in my scroll routine where I'm not working right here. So LDX 0, start off with X being 0. LDA, all that. Increase X. Compare X, is it 39? If not, then do it again. But it's not doing this. So what is wrong with this code here? LDX 0. Move everything. NX. Compare X to number 39. Branch if not equal. Back up to scroll 1 again.
That's good to me.
For some reason this isn't working. It's not even doing the LDA SDA operations.
Not?
No, I didn't see it move.
Did you test to see if it's going to scroll 1 by changing the border color again?
Yep. Here, let me
Because you tested the line above it earlier. What color did you change it to?
every time it branches to left 1, whatever the border color is, it decrements by 1. So it should go through all the colors.
Oh, I see.
My screen is still garbling up though.
Yeah, I see that. So what is that number that's changing that screen like that? Matter of fact, let me see if I can do it basic here.
What's making the screen garble up like that?
What number is doing that? What's affecting it?
Well, it looks like it's turning on bitmap mode and turning bitmap mode off, and then it's turning the screen off and turning the screen back on. And
I'm trying to see if I played with it. So 32 blanks the screen. 31. What's 32? 32. I think it's in 32. Let me just run a short demo here and look at it. So 24 to 32, right?
31.
31.
Yeah.
I just like 32 because of the space bar. So now it's the joke. Okay, so it totally blanked out. Now I'm lost. Getting back, okay.
Yeah, if your screen freaks out, you could just poke 27 in there and puts it back to default.
I'm going to set a delay in here so I can kind of watch the screen before it blanks out. And let me show you what I'm doing. Can you see that? It's doing it so fast you can't see it.
Yeah, I seen the screen like blank out on you.
So these bits right here, I wonder if I change that to 33.
No, it's got to be 24 to 31 for it to.
Well, I was just trying to see like which one does the high. In fact, let's look in the book.
See, that's the problem having a machine language. I just want to keep them numbers between 24 and 31, but it won't let me. It keeps on going out of that range.
Bit 5 is enable high resolution, which is 16. Let's see, 0, 1, 2, 3, 4, 5. No, it's 32. No, bit 5 is. No, I got that. No, I wrote this down wrong. So bit 0. Shucks. I spent all this time writing this bit chart out and I wrote it the wrong way. Give me a second here. There's no such thing as a bit 8. What am I thinking? All this time I've been thinking about bit 8, there is no bit 8. There's only 0 to 7.
Yeah, so basically bit 8, we're talking about bit 7.
Yeah.
That's the bad guy there. It keeps on flipping on and off on me.
That's what I'm working on right now. My own little logic here. 7, 6, 5. Wait. Wait, 24, I'm using the wrong one. I'm using 1001100, but 24 is 0001100, right?
Yeah, with the bit 7 off, it'll be 24, and with bit 7 on, it'll be 152.
I've been using the wrong one the whole time. Alright, let's see here. 120. Okay, so that's why you were right. I was looking at the other one. I was like, wait, he's using that one. Okay, no, I was looking at the wrong chart. My bad. I'm creating a bit chart so I can see exactly what bit goes to what number and what binary bit goes to that bit, so I don't have to look it up each time. I should have destroyed in Excel, but I'm just lazy. Section 4. We'll double check that. This is better than a computer science class. I used to get so intrigued by this one. Blows my mind. It's like you're discovering something new, you know? Okay, so let's see. I've got all the bits on. Match them for the bits. So 24 is 0001100. Okay. Now I know what bit goes to what value just by looking at my chart. I did this on the Atari computer a while back, but oh well. I lost those guys a long time ago. Where are the other people at? I don't know. I give up. Well, I guess we'll have no competition, right?
Absolutely.
We'll start writing these games to people. How you doing that? I'm like, well, start learning from the basics. Round up. Ground zero. Okay, so back to the bit. Now I can see here on my chart.
Oh, Lord, I finally figured it out. Thank God.
You're not using bit 5 for anything, are you?
No, what I did...
Graphics, man.
Do you have my screen share up showing the my code here?
I have it.
What I did here is I copied this code to here, but I had here branching back to left 0. Instead of,
Oh, I didn't.
so it was this line that was wrong. It had nothing to do with any pokes or peaks.
I was never getting there.
So now this should work for like the top 6 lines. Let's try.
6 lines or 7? We need 7. Well, technically 8.
No, I mean 6 lines on the screen. 1, 2, 3, 4.
Oh, okay. Let's go with the raster lines.
Yeah, I'm thinking my code is fixed. So let's test it out.
Roll routine.
What we want to see is that Commodore 64 Basic V2 end up being on the very top line.
Yep, that makes sense.
It is.
Bingo.
Now let's keep going.
Did you skip one though? Let's see, there it goes. Nice job.
It did. Let me turn off my border color change thing real quick here. Because we don't need that anymore.
It's interesting how you figured it out though, because you made it
Yeah, it was just right here. Or no, it was down here. I had a B and E left 0 instead of B and E left 1. So it was actually jumping way back up into the wrong part of the code.
so it was kind of repeating the raster beam thing.
Well, see, what my code was doing you know, what is 53265? Is it 24? Then branch to left 1. And what happened was when I had this be B&E left 0, when it would go to left 1, it would B&E to left 0, and then it would just RTS. So it wouldn't even go down here and move the screen. But now it's fixed. So now I'm ready to turn off the screen color changer. Don't need that on. Get that out of there.
So once we get this working, we can set up an area in memory and just scroll it, right?
Well, what this is going to do is every time you do sys49152, it's going to scroll the entire screen up by 1 pixel.
Yeah.
And even if we have to hard scroll, it does the soft scroll and the hard scroll both.
That's what that center section
This isn't going to bring new data onto the bottom of the screen yet, though, because I'm still only working with the first 7 lines. Remember, we didn't go through all those LDA, STA, 1024, 1264s yet. We gotta still finish that part first. So let's test it and see what we got.
Oh, we got a mini scroll. That's cool.
All right. A hard reset on accident, I'm thinking. Hold on.
Save it. Oh, well, you already got it. Yeah, make sure you save the 64 Studio Code. You don't want to start that all over.
Yeah, I'm in good shape there. Every time I compile it, it saves it automatically for me.
That's a cool thing. So we should get a scroll.
I know what I did. There we go. Maybe not.
The screen's off. There you go.
Now I don't want to scroll at all. Now where did I typo? Oh. Oh, when I erased when I tried to take out the border color debugger code, I accidentally erased a good part of code that I didn't want to.
I'm looking at the video for it. The original one is. I just froze the screen so I can show it to you. Copy my screen over.
There we go, it's going. Well, you can't really tell. Hold on. Let me just fill up the screen with a bunch of whatever, and then run it. All right. All right, now we're cooking, but now we just gotta finish off all them LDA, SDAs.
Mm-hmm. Let me go back there for you.
So my last one I did was 1304. So I guess the next one is 1344.
Yep, 1344.
And what, 1384? Yeah.
Yep. 1424. $14.64.
Uh-huh.
Did you get 1464?
Yep.
Oh, okay. 1504.
Got it.
1544. We can plug in the print them all. Okay.
So 1544, then 1584.
1624.
And then what, 1664?
Yep.
And then what?
1704.
We're almost there.
Mm-hmm. 13th line.
All right, then the next one.
1744.
Okay, then 1784.
Yep.
And then what, 1824?
Yep.
Then 1864.
Good. Yep.
Then 1904, is it? 1904.
Keep repeating.
Yep.
Twentieth line, and that should be the last one. 2024.
Yeah, that's actually beyond. That's actually past the screen. The screen stops at 2023.
Oh, 2023. Okay, here we
Yeah,
are.
so this is it. This should be it. This should make the whole screen go. All right.
Gotcha. You don't want to go beyond that point. Danger zone. I should start calling those danger zone. Stay away from danger zone.
Well, I can, but I mean, it'll just like load crap up at the bottom of the screen.
Well, it actually affects the sprite register, so you're not too bad off. But 2048 is the basic program. That's where you start overwriting your code. How many times I've done that before, I can't tell you.
It's telling me my relative jump is too far now. Ah, dang it. That's fine.
Don't go up to 127. So let's see what they did in example. They use the jump statement.
Yeah, I got it. I think. Okay, I do. Alright, let's test this thing out already. Hey, why aren't you moving? 10 sys 49152. Everything else did.
That's freaking weird. I wonder if we got some of the numbers wrong. Let me print them off real quick and check them.
Yeah, the whole screen's moving except for that one line.
I'm gonna double checking the numbers for you. Did a printout of them here. Do you want to check the numbers? Make sure they're all correct.
Yeah, something in the. I think we might have missed the line in the numbers, probably.
Actually, these are not correct. Hold on, what did I do wrong? Let's see, 2024 to 2023, you said, right? Plus 40 times L. I'm not kind of fun. Oh, I just added an extra one and I that helps too. First, those two lines are good.
Let me figure out which line it is here.
Let me see. I need to do something here. Oh, yeah, isn't this one over?
Looks like it's line 7. 1, 2. Aha, here it is. Wait. I think my eyes are playing tricks on me. Or maybe this program's erroring out. Let me make sure I got everything saved here.
Error now.
Yeah, the numbers were changing on me. Either that or I'm really tired.
Let me see what you got there. Oh, I only need to go to 40 this time. That's right. No, no, that's 0. Shush. Okay, I got the numbers on the screen now. So let's see, 1024, 1064, 704, 744, 784. I can't see all your numbers too, scroll them up. 44, where was I at?
I'm not going to be able to get them all on one screen here.
That's all
There
right.
we go. Here's the first set.
44, then we got 1184, 1224, 1264 is missing. Let's see, 12,
Ah,
there we go.
okay.
Which is probably where that line was at. About somewhere in the center. That makes sense.
So it's LDA 1264, SDA 1224. That should do it. That should have our routine ready for one single pixel movement every time you do the sys.
Mm-hmm.
No.
Why is that's freaking weird?
Okay, so where?
Let me see if that's where that line was. Was it 1064? What was that line you just added?
1264.
That's about right where that is. When I poke it on the screen, it sits down 0, 1, 2, 3, 4, 5, 6 lines down from the top. How many lines is yours down?
Let's see, 1, 2,
Starting with 0.
4, 5, 6.
It'll be down in the 6th line if it's correct. I can't tell by setting mine up side by side with yours. Looks pretty close. Might be off by. Should I shrink mine the size of yours? Yeah, exactly where that line falls. Matter of fact, poke in that area and see if that's where it is.
Okay.
Right where you're on this screen here, see if poke hits that line. Then you know. Poke 1264, 2 or whatever.
Yeah, I think that's right. Yep.
That's it.
So it's 1264 still ain't going, which means that apparently my code didn't recompile or something.
Hmm.
That ain't right. I don't want that.
I notice these longer videos don't get a lot of views, do they? People like get bored watching, I guess. It doesn't post the video on here until you're done, right, with the chat?
No, we're on there right now.
I don't see it in the video editor anywhere.
No, you go to your channel, it's going to say live. Like if you go to YouTube and do a search under Steve Morrow,
Mm-hmm.
you'll see you and it'll say live on it. And if you click right on the live, it'll bring you right into this.
Then why did the other one save it into a list of my, what do they call it, the video manager? It didn't save it in there.
Yeah, once you're done, it usually takes about 8 hours. YouTube will process the live hangout into a video. Then after about 8 hours, it'll show up in your video manager.
That's what it is. Okay. So we can't figure out how many people are watching it right now.
No, you just go right to the video and it'll say X watching now.
Yeah.
Right now it tells me 1 watching now.
One.
Yeah, I see 1 watching now.
I guess that would be us.
Yeah. It probably just counts as me or you, one of us, because we have it open.
Mm.
So it's still skipping that line on me. Did I miss something else?
Let me go back to the numbers again.
Ah, right here, right here. That's what it is.
What was it? Oh, you had to repeat the line?
Yeah, I did an LDA, STA, the wrong numbers.
Um, yeah, it'd be something simple.
Right?
It's totally cool figuring it out this way because we really understand it now.
And there it went. Cool.
Ammo. So when it scrolls up, where does it go from there? Like, how could we get it to scroll back down?
Well,
Yeah,
all this does is it moves the screen up by 1 pixel every time you call that sys.
that's kind of doing what the computer already does, basically.
So well, yeah, pretty much, except it does it as a fine scroll. It doesn't go one. It's not like pushing arrow down because that's not 1 pixel. That's like one whole character space.
Got it.
My sys will move at 1 pixel, 1 dot every time.
Gotcha.
So once it reaches the top of the screen, though, the top is just erased. There's nothing there.
That's what I mean. If we wanted to make a game where we could scroll up and down, though, you'd have to save it somewhere.
Yeah, this routine is good. All we have to do now is we have to add one extra line of code that will draw the new text on the bottom horizontal line. So after a hard scroll, we want to have it put everything. We want a new line put down here like that.
Mm-hmm.
And then when we scroll again, do another whole line. Here, you want to fire it? You want me to? I could copy and paste this to you. You want to fire this up?
Fire it up where?
On your WinVice.
Oh, yeah. If you want to do that, that's fine.
Yeah, I'll give you this to you real quick. Then get you pulled up on WinVice, and then we'll be together on where we're at here.
Let me save this.
This will be for you still got C64 Studio, right?
Huh?
Oh, did you say yeah?
Yes, I do.
Okay.
You know, one of the games I've always wanted to duplicate, to make my own. You ever played a game, Rick Dangerous?
Yeah.
That's a cool game. And it does vertical scrolling.
Yep, it sure does.
Well, it does everything. It does, side scrolling, up scrolling. Actually, no, wait. No, it only does vertical scrolling. I don't think it does side scrolling.
Yeah, with Rick Dangerous, it's you could go up and down, but it don't go left and right.
Yeah. It gets too confusing when you make it scrolling all over the place, so it's better just to do it in one direction. Like in command, well, I guess you could depending on the game, but.
Okay, in the next few seconds here, you will have the code.
Did you email it or what'd you do?
I sent it to youtube.com/inbox.
Oh, okay. I see it up there. Which I haven't checked that thing in ages. I turned off my feed because too many people kept sending me spam. So I don't even remember how you can use it now. Is it on the where you can get all the links for the live events and all that is? How do I get to the inbox?
You want to go to youtube.com/inbox.
Oh, that's simple. There we go.
And it's like a 1 pixel up scroll or something like that.
So I wonder if Todd's right, we could copy this into this code into BASIC like this, into the emulator. All I have to do is reproduce the lines, right? Let's see if it works that way. First, let's save this one so I don't lose this one. Another thing is it won't produce the line numbers though. Let's maybe if I could copy it in here into WinVice. Yeah, it's not going to produce the line number, so I had to do it line by line. Shucks. Can you see my screen?
Yeah. See, everything's a syntax error.
Just trying to copy all that code in there.
It's too bad you can't type it in like that. It'd be nice.
It's a bummer now you're in it all in. Because there's no line numbers. You'd have to self-produce the line numbers. Like I could draw them on the screen and make it, but then it's still not going to work. I wonder if I did that. Equals where you say 1,000. Is it 20 lines? Something like that. And see if I can paste them there. Think it'll work?
I'm not sure.
I don't know where to find out.
Yeah, maybe put the cursor all the way up to the top and then do the right click.
But I can only count down 10 lines. If I go off the screen, it's not going to get them all. 10, 3, 4, 5, 6, 7, 8, 9, 10. I do the first top 3 right here. Let's see what happens. Oops, I got paste. What the heck?
Oh,
It's moving all the way over there.
yeah, the enter is it's pushing enter for you too, so it's getting syntax errors.
Yeah, so it's forcing the lines in. Well, it took one line. So why did it do that? What if I did like that? I gotta stop it again. I'm gonna give up on this in a minute. Ah. See what happened this time. Nothing. So when it's pasting, where's my print line? It's erasing the. Okay, so what I'm gonna do is I'm gonna paste it. I'm gonna stop it if I can see it. Let me just do, matter of fact, let's do the top 2 lines instead of doing all 20 of them. And I can kind of figure out what it's doing. Because it's scrolling off the screen, I can't see what's going on. So it's inserting a semicolon. Why? You see that?
Yeah, my second line of code is colon jump scroll 1. That semicolon is making it so that line isn't executed.
Yeah, I forgot to do the line input. That was my fault. So I need to...
I'm not sure we're gonna be able to pull it off this way. Maybe load it up in C64 Studio, then we can do the next. You can help me with the next part, which is getting the new data to scroll in from off the screen.
I'll give up it. I just wanted to see. Go to one of the tricks. I'm going to stop right there. I had these numbers reversed. Well, it did one. So do you see what it's doing? It's forcing the next line down because it's reading all these lines over. It's reading all the, it's not taking out the white space, so it probably won't work. So upload it in C64 Studio. Why not?
Yeah, I'm not sure this would have worked for you because there's a lot of lines of code there, especially that part with all those LDA, STAs.
Alright, so get me started with a new project here. I just go to new project. Let me share my screen so I can share that now. Why does that camera keep popping up? Do you see my screen?
Yeah.
Okay, so new project.
Yep.
Good enough name, I guess. And a new ASM. Wait, there's a new ASM, right?
You got your new project going?
Yeah.
Okay. Yeah, then new ASM, yep.
Okay. I have to take off the top line. It's not gonna go in there otherwise. Okay, we're in here. And it formatted everything to the left.
That's funny. Because in the thing it was formatted well. In the inbox it was. Oh well.
Yeah, anyway.
All right, go ahead and click on the two down green arrows.
So I gotta save it again. Why did you do that twice? Do I have to rename it something else?
What happens when you click on the build and run with the two green arrows pointing downwards?
It opens the box. So I think I just saved it called something vertical project or whatever. I remember. Okay, there we go.
Okay, so now all I could see the code, but I don't see your Commodore 64 screen. Did that come up for you?
I gotta put that back now. That screen share is probably gonna open up 1,000 windows, but let's try it.
Yeah, you should be able to just click right on WinVice as an option.
Can you see, what can you see now?
Yep, I see the Commodore 64, but it appears to not be. Seems frozen or something. Oh, okay, because you weren't in there. All right. So now what you have to do is you have to do go to File and hit Soft Reset. And then type in sys49152. Okay, so it did it.
Yeah. Good.
So if you write a program like 10, yeah, sys49152, 20 go to 10, then fill up the screen with a bunch of lists or something, you should be able to see everything scroll up and away.
Oh, just print something on the screen?
No, just 10 sys49152, and then 20 go to 10.
Oh yeah, let's roll with that.
And then just type list, list, list.
Yeah. I think those are all the black blanking lines.
Yeah, those lines are because we're working with the border, not I didn't shrink the border or grow the border or whatever.
So they're part of the border. Well, anyway.
So all we have to do is we have to change the numbers in the beginning of the code up there.
Mm-hmm. That's true.
So what numbers do we got to use? Because between 24 and 31, that scrolls the screen, but you're going to see that little black line there. So to get that black line out of there, we got to set that bit that's going to make the border cover it.
Right there, 27.
Well, no, because between 24 and 31, the border's not going to cover that black line. Because 27, yeah, you don't see it, but as soon as you go to like 26, 25, it'll come back in.
Oh, that's right, because you're scrolling through all those lines. Good point.
So what bit do we have to set or clear or whatever to get the border to make it 23 lines or whatever it is?
Hmm. Doesn't say anything about the border.
In 53265?
Mm-hmm. There's a lot of reading to do to kind of go through it. Which is controlled by the border color register. Bit 4. Bit 4, this register controls a screen blanking feature. When this bit is set to 0, no data can be displayed on the screen, so the whole screen will be filled with the color of the frame, which is controlled by the border color register. That's not it. That's the only thing I've seen on the border so far.
So which bit sets it to 23 column mode or whatever?
3.
Okay. So what is bit 3? That's 1, 2, 4.
Oh, which one is it on the map, you mean?
Yeah, that's 8, isn't it?
Yeah, it's 8.
Okay, so try go up there to poke 53265, 27 and add +8 on there. And that should make your border shrink.
You mean advocary 8?
Yeah, just go up to where on your Commodore screen where it says 53265
At the top?
Well, wait, go back to your Commodore 64, your WinVice first.
Oh, okay. You meant in the... Why did I got 2 of these open? Okay. I have 2 of them open, even know that.
So go ahead and go to that poke 53265 line and just add +8 at the end there. So it's 27 plus 8. And that should, nope.
Made sense. So if we took out bit A, we'd have to recalculate for what that binary would be. 1001000. Need a better binary converter. Let's see, convert decimal to binary. Oh, this is cute. Oh, I wanted to do that. I did that back, but dude. You said it was bit 4, right?
I think you said it was bit 4, so maybe it's got to be 27 plus 16.
The bit 4 is right here. Decimal value 8. The decimal value 8 when I take out that bit. That's interesting. There's only
Yeah, decimal 8 should have a 1 like... Yeah, it's 0, 1, 2, 3. Oh, that's bit 3 you got set to 1 there.
Oh, my bad.
So yeah, I think if you go back to WinVice, if it's 27 plus 16, I think that'll do it.
There it is, 16. Oh, what wrapped the numbers. This converter's not bad enough. So 16. It doesn't make sense. 16.
Yeah, give it a shot. 27 plus 16.
Nothing.
Still turned your still turned the screen off.
Type it anymore. Let's go.
Do we gotta turn the bit off or on?
Good
Maybe
question.
it's 27 minus 16.
0 is blank. So it has to be a 1. Bit 4 has to be on.
0 is blank.
Yeah, it says bit 4 blank the entire screen to the same color as the border. 0 would be blank.
Well, we don't want to touch that bit then. We want to leave that as it is. We want the bit that sets it to 23 column mode.
Oh, that's bit 3. Okay, so 0, 1, 2. So bit 8. So plus 8. Didn't we do that one?
So maybe try 27 minus 8.
Minus 8. Oh,
So yeah, we gotta turn the bit off. There we go.
that's what it is. I think backwards.
So what's 24 minus 8?
16, right?
I'm that lazy. I don't want to do that.
16. Oh no, I did plus. Okay, there I hit the minus key. 16, just like it's on the chart.
Okay, so now go ahead and go to C64 Studio. And on line 5, turn it to CMP number 16.
Interesting.
And then once you got CMP number 16 set to line 5,
Yep.
we also got to update line 22.
31.
It's got to be 31 minus 8.
Oh, 31 minus 8. Gotcha. That makes sense. $23.
All right. So the only thing you have to do then is before you call your sys request, first you want to poke 53265, comma 23. All right, so now when you do it, it should scroll up and have no more black bars.
So if I put that in the program,
Yeah, no, don't poke that every time, just the first time.
so what if we just do like a flag or something?
Yeah, you could have line 10 be poke 53265, then have 20 sys, and then 30 go to 20.
If that was less than. I'm using all. What the heck?
Oh, yeah, you got a soft reset.
What was that number again? 23?
23.
And just set this to a flag. All I had to do is go to that line, duh. There we go. I didn't need these other stupid lines. Like that. Nice!
Did it go up real good and smooth for you?
Yeah. Did you see it?
Perfect. So far, so good.
Yeah, we are rolling, man.
Now the next step we have to do is we have to, on the C64 Studio, anytime it jumps to left 1, my label left 1,
Let's see it.
we have to, at the very bottom of the code, right before that RTS at the end, we have to load up the bottom line of the screen with new data, with new characters.
So we're going to be loading in.
So what's the memory addresses on the bottom line? What is it, 1944 to 1984 or something?
What was the maximum on the screen again? 2023?
2023, yeah.
What happened? Oh, it's one more over. 1984.
Now is that the bottom line or the second to bottom line?
That's
Because
the bottom line.
2023 should be the very bottom right-hand side.
Let's see, if we go 1984 plus 40, we're over. So yeah, 1984 is the bottom line.
So right where your cursor's blinking, is that 1984?
Mm-hmm.
Okay. So that's what we got to fill. We got to fill in between 1984 and 2023.
So it's going to make a program here to add
Yeah,
it.
right. Yeah, right before that RTS there, you got to put in the code that's going to fill something in between those two, that 1984 and 2023.
Can we stick like a Y register in here or something? And just draw all on the screen or something? Is that what you're saying?
Well, I tell you what. Let's take what's on the top line and copy it to the bottom line.
No, that's interesting.
For example,
How far up? Just the top one only?
well, not here. You don't want to touch this code because everything's perfect here. We want to be at the bottom right before the RTS there.
Yeah, well, I was going to copy this and move it down there. You want these two lines?
Okay, between, what is it, 1024 and... Yeah, okay, so, yeah, let's copy what's on 1024 through 1063 to that bottom line. And then it'll wrap the screen around every time.
So like that?
Oh, let me zoom it in a little bit.
Sorry they don't have the zoom feature on this. I don't think they do. No zoom. I can zoom with Microsoft. I don't remember how to do it. I think it's Control key.
I think it's Control Plus.
Yeah, I got it.
Ah, there we go. That's good. Oh, you don't have to be quite that big.
Downsize it a little bit. Like that?
There you go. That's good. All right, so we're probably going to want to make a loop that counts from 0 to 39. You're going to want to use the X register.
We're already using the X register.
Yep. So right below B and E, scroll 2. You're going to want to put a LDX number 0 in there. LDX pound 0.
Can we reuse it that way without affecting anything?
Yeah. And then below that, we're going to want to make a new label. What would you like to name it?
Doesn't matter. Copy. Right.
1P?
Yeah, well, LP, like loop.
Oh, LP?
LP one or whatever.
Yeah, I think my labels are left 0 and left 1, so I think loop 1 will work. All right.
3. Well, it's not left, it's still a loop because we're looping.
Yeah. All right, so
we're going to draw in.
So what you want to do then is LDA 1024, X, which is, you actually got it down there, LDA 1064, X. So you want to switch that to LDA 1024, X.
What happened?
Yikes! Everything scooted over on me.
Yeah, I don't know why you did that. Magnifier, how do you get that screen back over? Come on. And it moves it, so when you move the mouse, it moves the screen. I get it.
Cool.
Okay. Can you see it now?
Yeah.
Okay.
So go ahead and erase that LDA you got after loop 1 there.
Erase all this down here.
Nope, just the LDA that's right next to loop 1 there. Go ahead and erase that.
Oh, I thought you wanted that.
And then go down to where it says LDA 1064, go to line 108 and switch that to LDA 1024.
Oh, I see. That's right from the box. Top line.
Okay, so LDA 1024, STA 1984, that seems good. And then we're gonna, and on line 110, we're gonna want to put a what, a INX, increment X. And then 911, you're gonna want a CPX number 39,
Just put it in there.
and then B&E loop.
Like that.
Yep, I think that's ready.
Screen back. Right. Yeah, nice job.
Beautiful.
Yeah, it works so awesome, man.
So that's pretty much what you gotta do, except that you have to put something new on that bottom line to get new stuff to come up.
So that's what the scrolling effect is all about. It has nothing to do with memory. It's just basically repositioning whatever data they want to show back up.
Yep.
So basically, we could set byte statements and scroll through them, right? Like, how do you do the bytes on here again?
Exclamation byte.
Exclamation byte. Like that? Maybe just that byte. I don't know.
Yeah, but doing this though is going to put it way up somewhere in high memory though.
That's what we want to do. We want to be able to scroll through a set of data. So like
Okay, then well you gotta know. So then you want to know where that memory location is because you have to LDA from there, then SDA in the 1984.
yeah, we'll set it up to read this area, just like call this data or whatever you want to call it, and just read that into the X register up here instead of reading the screen. And then we're going to point to that area of memory, and then whatever later once we redefine a character set, we can have a nice example going.
Yeah, set it up. Let's see what we get.
I'm just going to put a bunch of A's on there.
Cool.
A's and B's. How many we got? That's what we need on an extra line. How many did you stick on the line? 8?
A column is 40 bytes.
Yeah, it's going off the screen though. I wanted to kind of make it
Oh, I see what you're saying. For the okay, yeah, just yeah, you could just go like in the middle there, push enter, and then type exclamation byte again. You know.
a certain range. And all we gotta do is just why is that one short? Oh, over here. Just copy these and it's just change the numbers again. It'd be easier to do it the second time around. Like that. Now I have to go back and have to rename them.
Okay.
there was no copy function. Yeah, I can do it this real fast. Let's do a copy. Save some time. Like that. Is that enough lines? Should be 39 and 39. Do we need 40? I got started at 0.
Yeah, it's 40. It's 40 bytes per line per column.
That's 39, so I need one more. Okay, so now we just need to read this data, and imagine you just say data X, right? Can you do that? Read our data? Does that work?
I think so.
Okay. I asked because I saw that you did something similar on the other example. No, you're not getting me this time. The 23, was it?
Yeah. Oh, nope, you want to go to 20 there.
Oh, my bad. Yeah! Woo! Wait, where's the bees?
Looks like spades. Are those spades?
Yes! Where's
So
the
good.
bees? I didn't read the bees in.
So you poked 65, 65. Is that what poke 65 is?
Yeah, I didn't read these down here, though. It should be like doing this, doing this, doing this, doing this. You know, it should be alternating.
Well, here, go ahead and take.
Just gonna throw in a random one in there.
You see, yeah, just put like a bunch of numbers like on the first part, 65, 32, 18, or whatever.
I'll test it out and see if it's gonna pick them up or not. Now we gotta do is redefine the character set, and we'll have a pretty cool demo going.
Yeah, you can now go into Charpad and make a vertical screen as long as you want, and then you'll be able to put it right into the memory, and then scroll it like that.
I still haven't learned how to use that thing yet, but I'd like to. Save that for another session, I guess. So there's the A's.
Hey, you got some A's.
Let's spruce this up a little bit. Add some color. As a matter of fact, we could do that in here, but you didn't set the color register, so we'd have to add all the color in here. Colorize those lines next.
Yeah, we're gonna. Yeah, you have to do the 55296 and all that to get the color to move. Bad thing about that is that it's very. You're gonna be pushing the processor too hard.
Why?
Cause that look how many LDA STAs are going on already.
You mean up here?
What is that? What is it? 6,000 LDA STAs that happen per loop.
Mm-hmm. Because you're executing them over and over again. Interesting.
That's a problem I ran into is being able to move the color memory too. It's really hard. The raster beam gets in the way every time.
Oh, that's what you were talking about. And this, what you're talking about here is exactly what needs to be done. I read that in a book. It's just about you had to reproduce the next line down. I'm like, what does that mean? Until you did it tonight, I didn't understand. But why is it not reading this part? I don't know. It seems to be skipping this. It seems to only be reading this. And it doesn't understand any of this. Do you know why it's doing that? Do I gotta stick them all on the same line? I mean, it's a simple solution, but it doesn't make sense. machine, it's not going to be as simple as I thought. Because we're scrolling the bottom line. That's going to be on my chart anyway. I'm just curious. What do you think that'll do? Are you there? Let's see here. What the heck is it doing this for? Reading 39 lines. Maybe I have to put it down here. 39 lines. Read the next one. Okay, let's see here. Lost you. Where'd you go? He's got to get up. Well, guys, I guess we're going to wrap this one up. But you've seen it. We've accomplished scrolling. This has been a very long video, I know. I want to thank you for joining us this evening. I don't know where Bo went to, but yeah, we've done some pretty cool stuff here. I think we're going to be able to work with this and get a really cool scrolling demo going. Eventually, probably some of the next steps will be able to work on like horizontal and actually down scrolling, left and right scrolling and whatnot. So I think this has been a really cool session. So definitely go ahead and subscribe if you're interested, and subscribe to either one of our channels, definitely. And thanks for watching, guys. Appreciate that.